Hello learners, in this block so far we have studied about hydrosphere, the different realms of hydrosphere. You have also learnt about ocean floor and bottom reliefs. So now you are acquainted with the terms like continental shelf, continental slope and deep sea plain, oceanic trenches, etc. You have then studied about the physical properties of the oceans in terms of distribution of temperature in the oceans, distribution of salinity in the oceans, and then we studied about the oceanic circulations in the form of waves, tides and ocean currents. And in this video program we will study about ocean deposits and different types of ocean deposits. We have bifurcated into two types, like on the basis of area of occurrence or on the basis of location, and then on the basis of its source and composition. So in this part we will start off with the second classification of ocean deposits, and the remaining portions will cover in the next video program on ocean deposits part 2, in which we will cover about the horizontal and vertical distribution of ocean deposits and also the transportation of ocean deposits. So what are ocean deposits actually? They are unconsolidated layer of sediments lying on the ocean floor. And its study is important because oceans, are the final repository of all debris from the land. They are not a part of crust. So ocean deposits, as I told you, are unconsolidated layer of sediments. So they are not a part of crust and hence they are not lithified. And their thickness ranges from a few meters to about 700 to 750 meters at different places in different oceans. And their study also reveals the earth history, as they must have been deposited in several layers even since the beginning of the origin of the earth. So it is important for you to study ocean deposits as well, apart from other things you have already studied regarding the oceans at this stage. So there are various expeditions, but the most popular expedition was the Challenger expedition of the famous oceanographer Murray, which was conducted between 1872 to 76, and it has been the basis of several unknown secrets of the oceans. So Murray has classified ocean deposits as terrigenous and pelagic. I will explain these terms later, just in this video program, when I explain the classification on the basis of location or area of occurrence. And then there was another oceanographer named Jetkins, who classified ocean deposits as deep sea deposits, which is beyond 100 fathoms, shallow sea deposits which is up to 100 fathoms, and littoral deposits which is between the high tide and the low tide. So on the basis of area of occurrence, we divide ocean deposits into continental or terrigenous deposits, neritic deposits and pelagic deposits. So continental, as the word suggests, are those deposits which are continental in origin, and the word terrigenous is a Latin word which means derived from the earth. Terra means earth and genere means produce. It includes the continental rocks. It consists of both littoral and shallow water deposits, and there is also a kind of gradation in these deposits. As you know, there are coarser to finer deposits. The coarser ones are deposited near to the coast and the finer ones are deposited at greater depths into the ocean area. Can you reason out why? Because the carrying capacity of the waves decreases, so the coarser ones or the heavier ones are deposited only near to the coast. So a kind of gradation is formed from coarser to finer deposits. And quartz is the most dominant element for both littoral and shallow water deposits. And littoral deposits are also dominated by calcareous shells, which are organic in nature and formed by the decomposition of shells of various animals or organisms which live in the shallow water area. Now what are neritic deposits? These are also formed of the deposition of shells and skeletons of various aquatic creatures like shellfish, mollusks, etc., which are distributed over the entire ocean. However, the whales carry their eggs to the shallow water region, so they are predominantly found up to a depth of 50 fathoms, but they are even found in deeper areas. They have been reported in deeper continental slope areas also. Now, what are pelagic deposits? These are much deeper, deep ocean deposits which are found mainly in the deep sea plain, and they cover about 75.5% of the oceans. These deposits are formed of three types of organisms, organisms whose roots are attached to the bottom surface are called benthos, and the second set of organisms are those which have well developed locomotory organs, they are mobile, so they are called nekton. And the third group of organisms are the unicellular organisms like protozoa, diatoms, etc., which are called planktons. So these three classification of organisms was given by Johnson, and the pelagic deposits mostly consist of decomposition of these organisms. And red clay actually also forms a part of pelagic deposits, and in this figure you can see the continental shelf area is dominated by neritic deposit, then you see the continental shelf break area, and then slope area is also having a few sediments of few deposits of neritic ones. And then the deep sea plain, deep sea oceanic area is dominated by the pelagic deposits, and the shore area or continental shelf area, the shallow water area, is deposited by the continental or terrigenous deposits. Now let us study the ocean deposits on the basis of its source or its composition. Sources play a major role in determining the composition of ocean deposits, and sources can be varied. So, ocean deposits are also classified on the basis of its source or the composition. So, we will study in this type of classification different sources from where the deposits come, and what are its composition. We will focus more on the composition. So, this is more a detail. In the previous classification we studied on the basis of its location, like terrigenous, then neritic and pelagic. So, mainly terrigenous and pelagic is the deep ocean deposits, and terrigenous is the shallow ocean deposits, and neritic is also forms between up to a depth of 50 fathoms. And in this we are focusing, in this type of classification based on its source and composition, we are focusing more on the composition of the deposits. So, on the basis of composition, we divide ocean deposits into terrigenous deposits. Again we will focus on the composition part, and then it will be a detailed one. And then we come to volcanic deposits and deposits related to organic remains, inorganic deposits, red clay and extraterrestrial matter. So, you see there are different sources: volcanic sources, organic remains, inorganic remains, red clay. These are all different sources, and so their composition is also different. So, you might get questions in your examinations related to give the different types of ocean deposits on the basis of their source or composition, and then you may attempt this type of question, and you give the details of the composition of all different sources of ocean deposits. Now again in terrigenous deposits, I will not go into the introduction because we have already become acquainted with these deposits, that they are continental in origin, and they are composed of gravel, sand, clay, mud, which results from the weathering and decomposition of continental rocks, and transportation of these rocks, these disintegrated and decomposed blocks, takes place by various agents of erosion like rivers, winds, glaciers, etc. You all have already studied the normal cycle of erosion and various agents of erosion like these rivers, winds, glaciers in block 2 on lithosphere. of this course on physical geography. So you are now acquainted with these. So all these erosional agents bring sediments from different sources and finally they deposit in the oceans. These terragenous deposits, as I have already explained, also consist of both coarser and finer sediments which gets deposited nearer and farther from the coast respectively. As I have told you that the coarser ones gets deposited near the coast and the finer ones are deposited farther from the coast respectively. On the basis of texture, chemical composition, nature of constituent rocks, these terragenous deposits are divided again into gravel, sand, silt, clay and mud. Let us study these in detail. In this table, you can see the size in diameter is given of different terragenous deposits. Like gravel is having the highest diameter which ranges between 2 to 256 millimeter, and the mud is the finest amongst them, which is whose diameter is even less than 1 upon 8192 millimeters. So you can imagine it is so minute. And let us study the gravels first. So it is coarser terragenous deposits. Bigger ones are of the order of 256 millimeters and the smaller ones are of the order of 2 to 4 millimeters in diameter, and they get deposited along the coastal area, especially along the continental shelves, and form pebble banks. Or you might Google search as pebble banks and then you can see the images of pebble banks there, how these gravels are deposited. Now sands, they are also formed due to weathering of continental rocks. Their diameter ranges from 0.166 millimeter to 1 millimeter, and the coarser ones are of the order of 0.5 to 1 millimeter in diameter, while the finer ones are 0.125 to 0.166 millimeter in diameter. They are also carried by rivers as prime agents of erosion, and the finer deposits are of the silt, clay, mud. They are much finer sediments and are deposited in relatively deeper parts of the oceans. Their diameter ranges from 1 upon 32 millimeter to 1 upon 8192 millimeter, and the clay acts as a cementing material. These deposits basically have a heterogeneous composition and have aluminium content in them. Unlike sand, they are devoid of quartz. Now let us study the type of muds. There are also various types of muds that are deposited. They are classified on the basis of their distinct colors, like blue mud, red mud and green mud. Blue mud, as the name suggests, is bluish in color, actually bluish black in color, and these are disintegrated from rocks containing iron sulfide. Therefore the blue color is there, and sulfur reduces iron to ferrous state. However, the upper layers of this mud continues to be in the ferric state. Blue muds contain about 35% of calcium carbonate, and they are found mostly in Atlantic Ocean, Mediterranean Sea and Banda Sea. Now red mud, as the name suggests, is reddish in color, and the color is imparted by iron oxides, particularly ferric oxide and ochreous matter. Now what is this terminology, like ochreous matter? So ochre is an earthy, powdery, red, yellow or brown iron oxide that is used as a pigment. For example, yellow or brown ochre and red ochre. So yellow or brown ochre is mostly the limonite thing, and the red ochre mostly comes from hematite. Ochres are also clays strongly colored by iron oxide, which was defined as such by Hoffman. Gribble defined ochres as brown or yellow earthy forms of limonite. So these are actually the ochreous matter which I am talking about. So the color of red mud is imparted by ferric oxide and the ochreous matter. it has an average of 32% of calcium carbonate and is mostly confined into the Yellow Sea or Atlantic Ocean along the Brazilian coast. And red mud is limited to localities where a large amount of ochreous matter is carried into the oceans by big rivers. Now what is green mud? So this is also green in color, so the name is given green mud, and it is because of the presence of gluconite or silicates of potassium and iron which is found in them. So that is imparting the green color in it, and these are found especially at places where coasts are devoid of big rivers, and so continental rocks along the coast are exposed to denuding action of the sea. In course of time, the green silicates of potassium and iron are deposited on the rocks, thus imparting its green color. And these have about 7 to 8% gluconite and only 0.5% calcium carbonate. So in this video program, we got a brief introduction to ocean deposits, and we studied different types of ocean deposits on the basis of its area of occurrence or location. We started studying types of ocean deposits on the basis of its source and composition. We have completed the terrigenous deposits and different types of terrigenous deposits based on their composition and texture and color. In the next video program, we will also study the distribution of ocean deposits with the help of map, and then in the map you will see where these deposits are mainly concentrated. And after we complete this video program on ocean deposits, we'll have one program specially for the learning outcomes of all the video programs. After viewing these video programs, now you will be able to distinguish between two things, or what are the learning outcomes. Like in the beginning of these video programs, I have just given, like in this video program I will be teaching this, and after in the next video program I will be teaching something else. But after I complete all this this complete block on hydrosphere, we will focus on the learning outcomes, like what have you actually gained from these video programs. So keep watching, and in the similar way we will be studying the separate blocks on atmosphere, lithosphere and geotectonics. Thank you.